with a simple method called divide, which gets two arguments, a numerator and denominator. For simplicity, I have left out the other methods. In Program CS, we simply instantiate that calculator and then call the divide method. We are sending 0 as the denominator. Let's run the application. The application crashed, and this is something that we need to avoid. Let me cancel this here. Take a look at the console here. It says unhandled exception. And that exception is of type system.divideByZeroException. Divide by zero exception is a class that resides in system namespace. So in .NET, an exception is essentially a class. And here is the message about that exception. Attempted to divide by 0. And the rest is what we call a stack trace. A stack trace shows the sequence of methods that were called until the exception was thrown. In this case, we got the exception at this divide method, which is defined in the calculator class in the exception handling namespace. And that happened in line 7. And before we called that method, we were here in program main method in line 9. So this is the stack trace, which shows the sequence of method calls in the reverse order. Let's close that. Now to handle exceptions, we use try catch blocks. Something like this. So we put the code that may throw an exception inside the try block. When an exception happens, the catch block is executed. If there are no exceptions, this piece of code will not be executed. So in this case, let me move these two lines here and a try. In the catch block, we usually have two choices. We can recover from the error and prevent the application from crashing, or we can what we call rethrow the error. That means send the error back to the caller of this code. In this case, because the main method is the starting point of the application, it doesn't make sense to rethrow the error. So what we're going to do here is just to display a user-friendly message to the user. Now, if I run the application again, see, this time the application didn't crash. We just got an error here. And this is better. It's not ideal, but it's better than an application that crashes. So as a guideline, you should always have a global exception handling block in your application. Now here we are using a console application, and each console application has a main method. That is the starting point of the application. And here is where we have our global exception handling block. If you're creating an ASP.NET application, you don't have a main method there. And there is a different way to implement something like that. I believe in Windows Presentation Foundation or WPF applications, we should have a similar main method. Honestly, I don't remember because I haven't done it for years. Now let's take a closer look at exceptions. Here in the catch block, we just have a type. And that exception is the parent of all exceptions in .NET. It's good to have an argument here so we can access the actual exception. Now I'm going to put a breakpoint here using F9 and run the application in the debug mode with F5. Let's take a look at the X argument here. Take a look at these properties here. Message is the error that is associated with the exception. Source is the name of the application that generated the error. Sometimes your application might have multiple assemblies or DLLs. So more accurately, source represents the DLL or the assembly that this exception happened in. Stack trace is what I told you earlier. It's the sequence of method calls in the reverse order. So if I click this magnifier icon here, let's take a look. So the exception happened at this line 7 of calculator.cs file, which was actually the divide method in the calculator class. And before we got to this method, we were here. Now this is a very simple application. In real-world applications, you often see the stack trace includes quite a few number of method calls. Now let's close that. Target site is the method where the exception happened. So these four properties are pretty common when working with exceptions. Inner exception represents an exception that could be inside this exception. I will talk about that a little bit later in this video. H-result, to be honest, I have no idea what it means. I believe it comes from the world of Windows programming and it probably has a handle to the exception. I really don't know. Help link sometimes comes with some exceptions and obviously that's a link where you can find more about the exception. In this case, nothing. It's null. And data, sometimes exceptions can carry more details with themselves, which is stored in data. Let's stop the debugger. When handling exceptions, you can have multiple catch blocks, and they have to be from most specific to most generic one. What do I mean by most specific or most generic? Well, if you remember, the actual exception that happened here was a divide by zero exception. Let's take a look at divide by zero exception class. So I type in divide by zero exception here, and then press F12 to go to Object Browser. Look, here we've got divide by zero exception, and on this side, take a look, it derives from system.arithmeticException. So this is the parent. If I click this, it shows me that that class derives from system exception. And if I click this, it shows me that system exception derives from system.exception. So here we have a hierarchy of 4 levels of exceptions. The exception class is the parent of all of them, which is the most generic one. And divide by zero exception is the most specific one. So back here, let's say if our divide method could throw different kinds of exceptions and we wanted to handle each differently, we could have multiple catch exceptions here. So we start with the most specific, divide by zero exception, then more generic one, which would be arithmetic exception, and the most generic one, which is the exception one. Why do they have to be from most specific to most generic? Because in C# or any object-oriented languages, you should know that this parent class can hold a pointer to any of its children, which means if we put this at the beginning here, any exception that happens, that catch block would immediately get that. So we won't have a chance to handle specific exceptions like this one here. And as you see, C# compiler is intelligent enough and is complaining about the order of catch blocks here. And that's why we get this red underline here. So I'll put this catch block back to where it was. Let's go ahead and write a different message here. So console.writeLine, you cannot divide by 0. Now if I run the application, this is the message we get. So this catch block was executed and it recovered from the exception. So these two were not executed. In C# we also have a finally block, which looks like this. Let me clean up some code here. Let's get rid of these. Okay. So why do we need finally block? In .NET, we have classes that access unmanaged resources. What do I mean by unmanaged resources? That is, resources that are not managed by CLR. So there is no garbage collection applied to them. Examples are file handles, database connections, network connections, graphic handles. And in situations like that, we need to manually do the cleanup. Now, any class that uses unmanaged resources is expected to implement an interface called iDisposable. Let me show you iDisposable here. iDisposable. So we press F12 to jump to Object Browser. Look, iDisposable is an interface and has a method called dispose, which is where we do the cleanup. And here the summary specifies, defines a method to release allocated resources. So we use the finally block to call the dispose method of the class that uses unmanaged resources. Let me show you an example. So I'm going to get rid of this calculator here. Let's define a stream reader. A stream reader is a class that is used for reading files. So I can say read a file located in C drive and is called file.zip. In the try block, I can read the content of this file. Say stream reader dot read to end. And here in the finally block, what we need to do is call stream reader dot dispose, which comes from iDisposable. So with this code, if anything goes wrong inside the try block during reading the file, you want to make sure that the stream would be closed. This is extremely important because if you don't manage these situations properly, you will end up keeping files open on the disk or keeping network connections open or your database connections, and sometimes you get out of resources. So make sure whenever you're using unmanaged resources, that is files, databases, network connections, graphic handles, make sure to dispose them here. Now in terms of execution of this piece of code, first this try block is executed. If there are no exceptions, this catch block will not be executed, but the finally block will always be executed. And if we happen to get an exception here, we'll just write this message to the console. And finally, we'll close the stream reader. Let me show you that in the debugger. So let's manually throw an exception here. We can throw an exception using the throw keyword. And just call it an exception. Oops. So I put a breakpoint here with F9 and run the application in the debug mode with F5. Well, interesting scenario. In fact, we got an exception right at the beginning here. This file actually did not exist on my local C drive. So in this case, note that we didn't actually write a proper exception handling code. So let's stop the debugger. This means if I run this application, it's going to blow up. We got an unhandled exception and the application crashed. So a better way was to actually write this here. Inside the stream reader is not initialized properly here. So the more reliable code is to say if stream reader is not null, then dispose it. Now let's remove this breakpoint here. So I press F9 again and put it here. Now I run the application in the debug mode with F5. With F10, I continue execution. So the control is here. I continue execution with F10. We display the message on the console. And note that the finally block always gets executed. In this case, stream reader is null, so it wasn't initialized and it won't be disposed. That's it. Now there is a cleaner way to write this code. We have a keyword in C# called using. So instead of declaring a variable outside the try block, then initializing it here, and finally checking if it's not null and disposing it, we can use the using statement. Let me show you how it works. So basically I come here, using var stream reader equals new stream reader. I get rid of this one here and I don't need this. I need this, put that here, and we don't need this finally block. So basically, when you use the using statement, internally, the compiler will create a finally block under the hood, which will call the dispose method of stream reader. So you don't have to manually call that. Now inside the using, we can read the content of the file. And of course, this is our global exception handler, which should be here no matter whether we are using the using statement or not. So let's run the application again. Good. So the application didn't blow up. So the using statement is the preferred way as opposed to creating a finally block and calling the dispose method. So at this point, you should have an understanding of how to handle exceptions. You have seen the try block, you have seen the catch block, you have seen multiple occurrences of the catch blocks from the most specific to most generic ones, and you have also seen the finally block. But how can we create and throw custom exceptions? And in what scenarios do we need that? Take a look at this YouTube API class I have implemented here. Let's say you are creating a website, and as part of that, you need to get the videos for a given user and display them on a web page. So this YouTube API class encapsulates all that logic. It gets the username of the given user and returns a list of videos. So here the code would look something like this. Here we have a try catch block. Inside the try block, we access YouTube web service. We probably may have to open a network stream, read the data like as an XML, and then parse it, create a list of video objects, and let's not worry about that low-level complexity. But what matters here is there could be quite a few number of reasons where something could go wrong during fetching videos from YouTube. And often they would be very low-level exceptions like network stream, I don't know, parsing exception, whatever. You do not want to expose these lower level exceptions to the higher layers of your application. So in situations like that, you may want to create a custom exception called YouTube exception and handle it differently. For example, when recovering from that exception, instead, maybe you may want to display a list of default videos instead of YouTube videos. So let's go ahead and create a custom YouTube exception. First, I create a class here, public class, call it YouTube exception, and that should derive from system.exception. Now with ReSharper, I select this class, I put the cursor here, press Alt and Enter, and enter again, and it moves it to a separate file. Typically here, what we need to do is to create a constructor. So I type in ctor, that's a code snippet, press Tab, and got the constructor. And here we need to define two arguments, string message, and exception, inner exception. So with this constructor, then we can call the base constructor of the exception class and pass that message and the inner exception. That's all you have to do. Then in YouTube API class, let's say in the try block, something could go wrong here. There could be low-level exceptions. We can catch all of them here. Maybe we would like to log them somewhere. And finally, we would like to wrap them inside a more meaningful exception like YouTube exception. So here, as a message, I would say, could not fetch the videos from YouTube. So this exception is a lot more meaningful than, say, a low-level socket exception or parsing exception in the XML. And as a second argument, I can pass the actual exception, which will be wrapped inside this YouTube exception. Why do we do that? Usually for troubleshooting. So when we are troubleshooting the application, we look at YouTube exception and then look at the inner exception to see what is the actual problem that happened. So as you see, to throw an exception, we use the keyword throw and then new and the type of exception. Let's throw an exception here just to simulate how this would work. Oops, some low-level YouTube error. So in the try block, I'm manually throwing an exception to simulate a real-world scenario. Then I will catch that here. We don't have logging yet, but I'm going to encapsulate that actual exception here inside a more meaningful exception. Let's go to our program. And in the try block, let's create an instance of YouTube API and call the get videos method and pass my name here. Sorry, var videos equal that. Now what we can do here is that exception would essentially be a YouTube exception. So if I display the message for that, let's see what happens. Run the application. Could not fetch the videos from YouTube. Let's run the debugger and see exactly what is happening. So I'm going to go to YouTube API, put a breakpoint here, run the application in debug mode, continue with F10. So we throw an exception and we catch it here. This exception is of type exception, system.exception. And the message is, oops, some low-level YouTube error. Now here we are throwing a new YouTube exception, wrapping that low-level exception before. So as we come out of that, we will get to the main global exception handling block inside our main method. If you look at that, X, let's continue execution by F10. Let's take a look. It says could not fetch the videos from YouTube because this is our custom exception. And if you look at the inner exception, it says, oops, some low-level YouTube error. So in the real world, when you use something like Entity Framework, which is used for accessing database, you're going to see that inner exception all the time. You get more generic exceptions, and then you keep looking at the inner exception to find the actual reason something went wrong. Well, that's it for this video. I hope you enjoyed it, and thank you for watching.